everybody, welcome to the testing session. It's an introduction to unit testing. And yes, we can have some questions here. First of all, we have to take a little bit care about the theory. We have some basic testing and we have a more structured overview to what we are doing here. And finally, we'll focus on the unit testing. And after that, we will have some going live with TESSY. It's a testing tool from Razorcat, developed and distributed and maintained by Hitex. So here we will have all the theory going live, and depending on the time, we will have some more additional features. Easy your life. Let's go ahead. Yeah, famous example, Blinky. Yeah, you know, if you're doing a Blinky, you're programming that, and finally you will take a look at that and you see it's blinking. So it's a very low level test of Blinky, and you see the development is always linked with the software testing. Yeah? Anyhow, it's maybe only visibility. If we take a look at what is going on here, I mean, we are really executing the Blinky because you see it's blinking. Here we have a famous example from TESSY. Anyhow, we have a range of scalar values, and we have the range with a start and a length. You see that here, and we can decide with a function if it's inside any given value inside or not. Yeah. With a static tool, you can check parts of that, but for the execution, that means for unit testing, the smallest testable entity will be the whole function. Yeah. For static, we can have value checking or overflows, yeah, syntax, but for the unit testing, smallest testable entity for C and so C++, it's a function, it's a method. I mean, I will refer to C, but anyhow, we can have C++. Okay, smallest testable entity, we assume now this function is value in range here. Yeah, it's a unit under test, it's a green pillar. And we have to do that test isolated. We have to do that one by one. So every unit has to be tested. And we really take a look inside that function here. For the inside the unit, yeah, we might have endless loops, yeah, all the things. But the intention is really isolated. Later we can see why. Okay, what's going on here? Yes, we have the function. We will provide data. For example, we have the start and the length of an interval, and we have a value to check that value if it's inside or not. So we have stimuli data, it's the input, range, length, yeah, the value, and we have expectations, inside or not inside. So we will execute that, and then after the test, we can see if the actual calculated value, inside or not inside, will met our expectations. That's a very basic principle. And here we can see the test data. Yeah, there's a microphone on. Here the test vector, test data, will always have input, stimuli, and output expectations. Okay, we can think about our timeline here. We have done some development. We have done the testing, the Blinky. Now we will collapse that to a V. It's a very common model. It's a V model. On the left side, we have the development. And finally, we get, of course, a lot of units, functions. Yeah. On the right side, we have the test of that, what we have done, so verification. So we will have test vectors and reports, the C coding on the left side. A more common approach is we have the requirements, we are going down, yeah, in the timeline. Requirements for a Blinky, architecture for a Blinky, detailed design specs for the Blinky, yeah, and finally we'll have the code for that. And on the left side here, we will do the static analysis. That means part of that code. And then on the right, first we have to do some preparations also during development. For preparing the tests, we can always do a test plan. And now we have the validation matrix. That means we have some test means, maybe a review, a unit test, component test, yeah, anything like that. So the validation matrix will tell us about how a requirement will be tested, by unit test, by review. After that, if we have detailed design specifications, based on that, we can do test specifications. And typically we'll use the classification tree editor or classification tree method for that. It's a graphic tool. It's very nice, very efficient. And if we have done the test specifications, the link matrix, we will set up the link matrix. That means we will do a link between a test and a requirement. Okay, of course, we'll have reviews. Now let's go ahead. We have the code and we have the specifications and test specifications. So we will do the lowest level. We will do the units isolated one by one, looking into the unit. Of course, we'll have reviews. We will have on a higher level the interaction of different functions. So software integration, software hardware integration, and finally we'll have the system test on a higher level, of course. Looking into details, we can see that this kind of testing might be also appear here on the left. It's called test-driven development. That means a more modern approach is, you will have some test specifications and you can modify, update your code. You can have nightly builds, of course, continuous integration. Okay, anyhow, if a requirement will be modified, we have the requirements management, and the traceability, the horizontal lines should indicate that. So here the traceability will give us the information if a requirement has been modified, which test, which function should we take care about. So it's very important to have from left to right, from right to left traceability. Anyhow, of course, also for the nightly builds, we have to have really stable behavior for so-called regression tests. We have spoken about that. So now let's really go to the unit here, to the details. So here we have this kind of unit. You see the green pillar again. It's a unit under test, so a function. And here we have the interface. We have the range and the value. And now we have the passing directions here, global variables. We might have pointers, an address, data of the pointer. And now I point that here to show you the isolation and why it's so important to have unit tests, every unit isolated, one by one. Isolation, I took a very nice slide from Frank from Hitex. So here we can see very easy. If we do not an isolation, I mean the function f1 will call f2. So here you can see there's a check maybe for null pointers. So we'll never ever cover that return here because it's prohibited by this if. So it makes sense. We can cut that. We will do this unit under test here, isolated. And if we do so, we can apply invalid values, null pointers, boundaries, all the things to have really the complete coverage. It's very important, and especially for embedded controllers, it's always interesting to take a look at that interfaces here. Later we will do that. Okay. Let's go ahead. Besides this simple interface for parameters, returns, global variables, in and out, we might also have subfunctions. And here we will take the isolation again. That means if we have one function, one subfunction, subroutine, one call, we can do a simple stub. That means we will not execute this function, but we can write user code for that, C code. Or we can do very simple, we can do an advanced stub. So here you see the crossing of the lines, red and yellow. The yellow is the interface, and here the red ones. That means with an advanced stub, I can simply have the interface of the subroutine as part of the interface of the unit under test. But of course, think about if you have a parameter here, you will have expectations to the parameter. And vice versa, if you have a return from the subroutine, it's in. So the interface is only changed, vice versa. Okay, so far the theory. Now let's take a look at TESSY, and I like to show you how you can do this unit testing. We have the TESSY GUI here. It's a new version, 5.1. So we have the test cockpit for the sources. Later here in the test project, we will have the tests. It's Eclipse based. So now let's make it alive. That means here we have an empty project. Yes, we have a C source here, but it's very simple. You can simply add that to a specific folder source root. Okay, so that we have the C source already, there's no test. In the overview, we have the structure. Left is the C source, right, we will do the testing. We have perspective, yes, it's Eclipse based, so we have a lot of perspectives, and in the perspectives we have views. So let's go ahead. Okay, we will set up a test for this is value in range. It's a C file, but it's a very simple one. So we can simply drag and drop that to the right side. So here, yes, we will be asked, no, we will not have any variants. We will take the standard default environment. I mean on the PC, the CDT, and we will do unit test. Okay. So let's go ahead, and now we will have the analyze. It's locked so far. And after analyze, we can get some information. So here we can see, yes, it's a very simple source, only one function inside. And it's a very simple function. You have saw that already. But what's going on here? I mean, now the C source has been analyzed. So I can select that one. And by the way, I can also do that here manually. So setup, but it's easier to have the drag and drop. Okay, so now let's go ahead and let's think about the interface. We have to go to the next perspective. So here we have the interface of this value in range, and also on the slides we can see that very good. So here it's a comparison between the interface. We have the range as a start, with start and length, and we have the value as inputs. Sorry. And we have expectations to the result, so you can compare directly. And this kind of analysis is already done. That's clear. Okay, so now let's go ahead, and now let's do a first test vector. What is a test vector? Yes, we will go to the test data editor directly, and then we will do a first test case here, new test case. So we have the test case over there. And again, of course, this interface here, this is the interface, this is the data. The interface will correspond to our interface settings. That means to the in and out. So we always have an input and output. Let's go ahead. Let's do a test vector. So here we have a start value of 5. We have a length of 2. We will check if 6 is inside. Yes, you see an enum here, so I can use this pull down, and yes, it's inside. Very nice. And if I do the save, you see now it's executable. Okay, let's do the next one. Maybe we will take one with no, that means outside, so I can have the copy, paste, and I have to modify maybe to 7, and it's no. Okay, and save again. So very easy. Now let's go ahead and let's execute the test. I mean, we can have also sequences maybe. So here you have only one test step, but we can also have a fixed order and time for sequences. And yes, you see the first test vector. Now you can see the actual and expected is the same. Great, green, But here you see we are expected no, but we get yes. Okay, so let's take a look at that. But anyhow, it might be a little bit boring. So I promised you also in the advertising, we will take care about where the tests will be executed. So Oh, we can do a report. Yes, of course, because it's the outcome of our tests. You get a PDF or HTML or docx format. You will see all the things. I mean, it's very boring for showing because it's only pressing a knob, but the PDF viewer has been opening now, and we have all the important data for functional safety. That means we will have company logo, and we will have a timestamp. You can see the kind of test. We can see metrics. We can see the source here, for example, the interface, and we have the test vectors over here. So it's green, it's a result, and here it's red. This is also sufficient up to this highest safety integrity levels. Let's think about where the test has been executed. I mean, here it was running on the PC, on the CDT, but in general, you might run the test on your hardware, on your simulator, depending on your environment. So here I will introduce a microvision. It's a Cortex M0 Plus. And I do not like to always destroy the flash by flashing. So I will execute the test from the RAM. Very simple. So let's do a new test. So that's very easy. Here we will have to take care about the executable binary. That means here we have this value in range, but for sure we need some startup code for the microcontroller, low level, and so on. TESSY will create C sources. So it's generating the test driver, and you can take a look at that. So we have startup codes, we have the instrumentation maybe. After that, you can imagine TESSY as a developer. So after that, after creating the C sources, the test driver, you will do the building. That means compiling, linking, and finally we'll get a binary. We have to load the binary into the RAM, and then we can run the tests, and we will load one test vector, one data after the other. That means we will do the stimuli, execute, we get the result. Next test case, and so on. So here, let's do that. Here we have you need a working environment, your project. A microvision project, you have a debugger, you have connection to the controller, and you are able to debug. Then the TESSY developer will start. We will provide the startup code. TESSY will use the Arm compiler, of course. And finally, we'll get the binary, and TESSY will provide the binary to the microvision. And the microvision is very nice. You can control that from outside with a microvision socket communication interface. Okay, so TESSY as a developer, TESSY can open the microvision, we can run the test, and TESSY will close microvision. Let's take a look at that. But first, of course, we have to do the new environment. That means maybe now we will do that manually. So here we will do a new test collection. Maybe it's a unit test on the G071. It's a test collection. Then we will do a new folder. Maybe we will name it RAM because it's executing from RAM. And then now, very important, take a look. We can have this unit. We can do a copy. We can do a paste. Of course, we have to tell TESSY, please use the microvision and not the default CDT. So based on that, maybe here we can have the RAM version of the G07. Okay. Yes, we have to analyze. Maybe we can take a look at that. And then meanwhile, maybe here you can see I have the nuclear board. So it's a 007. And yes, looking at the module, you can see it's a RAM version. Let's go ahead and let's execute. But now, of course, think about the test vector. We like to debug that. So we will no longer execute. We will do the execution as a debug. So now you can observe that, yeah, TESSY will generate the slave test driver, TESSY will build the slave driver, test driver, and then the microvision is opening on my screen, and now it's getting to the shared screen. And then you can observe that we are directly at the beginning of the test object. That means all the low levels have been already done. Yeah, so we are here at the beginning of the test object. Yeah, here we are. Yeah, is value in range. Yeah, now we are in the debugger. And here, for example, the program counter, it's 20 million. So here we are in the RAM. Yeah. Okay, let's go ahead. I will execute that. Oh, by the way, we can have a look. Maybe you can watch the TESSY current test case. Would be interesting, yeah? TESSY current test case. So it's number 1. Now let's execute. And now we are just going through the whole test, but now again, we are stopping at the debugging here. So we have the test case number 2, and now we can go inside. That means here, yeah, the V1, yeah, it's 7. So I will not jump into, once again, I will not enter that, and that's the bug here, yeah. So here we can easily replace that, or we have to replace that with a greater equal, and then we have the expectations. Okay, I will run that. So now TESSY will close the microvision, and we can modify the source. And so here, let's do a greater equal. Yeah, so 7 will be inside. Outside, sorry. Okay, so again, we have modified it. We will do a save. Of course, we will analyze the source. I will execute without debugging now. And you see, because it's faster on the CDT here, I switched to the CDT. Yeah, now we have the expectations. Yeah. So it's a very basic flow. You see all the things. We have done that. By the way, we have the microvision environment, but here with TESSY, you will get all the environments. That means here you have, let me say, hundreds. Yeah, for example, you always have the compiler and the target. So here you have the Arm V5 compiler. It's an old one. With the microvision PLS, yeah, Sega, or the Arm V6, yeah, with the debugger. We have famous things. ARM, we have Cosmic, Freescale, GNU tools for ARM, PowerPC, Green Hills, Hitex for the Aurix, for example, yeah. Or we have the IRR. So all the environments are available on your choice. They are all included in the license. Yeah, you are free to use one of those here. Yeah, Microchip, Renesas, Synopsys, Tasking, yeah, Tricore, Texas Instruments, Wind River. Okay. Only a short remark, but we can take a look at the RAM and ROM version with a microvision, and I'd like to show you, yeah, here we have the microvision socket communication, and for the RAM version, we will not do a flash. For the ROM version, TESSY will tell microvision to do a flash. So there's no impact. You have to have a working operating project, and the flashing and the ST link, or it's a mu link, and doesn't matter the debugger, yeah. It's part of your IDE. So TESSY is controlling the IDE and simply telling flash or no flash. Okay, we have done the test, but do you know if every line is tested? Probably not. So we will take care about the coverage, and we will do another test execution. So we will have the coverage, and it's going to the end. So once again, we will execute with coverage instrumentation. We can simply use everything here. Also, it's overlapping. Of course, that's nonsense, but we will get a pretty nice picture related to the coverage. That means an interactive one, coverage viewer. So here we have the pretty nice pictures, and we can take a look at that. So it's gray in the source. Here we have the MC/DC coverage. We have those lines. So you get information how the atoms here will be served by the test vectors. Okay. There are also famous metrics for the coverage. We can click on those here. Get some, for example, here some missing. Okay. I mean, the time goes by, so I will hurry up a little bit. We have the hyper coverage. Every part, every test will contribute to the coverage. To summarize, I mean, unit testing is very nice because you can take a look inside. Smallest testable entity. I mean, if you have only a read-write to a register, it might be not so efficient. But if you have a more complex functions, you can see the control flow. We can test really fault traps, for example. We have a fault injection for that. Okay, so we have some additional features, but I think we will have some more sessions like that today.